My name is Devin Hartsell.
And I'm Patrick Ausler.
And this is our final project for SE370. The data that we chose to analyze for this project was the Chicago crime data, which consists of all crimes committed in Chicago since 2001. We chose to also focus on education in Chicago with our project, namely student attendance rates and ACT scores. We hypothesized that wards in Chicago with the highest crime rates, namely theft, would result in the lowest ACT scores and student attendance rates.
To begin analyzing our data, we took the large crime data set inside of RStudio and started filtering and narrowing down to our relevant variables for our analysis. So we chose the 4 primary types of crime that we found relevant to possible crimes that students could be involved in to later relate that to our education data. So we chose theft, burglary, narcotics, and robbery. We also narrowed the year to where the data is only occurred greater than 2011 because our education data starts in the year 2011. Our final crime data cleaned variable or data frame here will be used later throughout for our analysis. We followed a similar process for our education data, starting with school data 2011. We selected the relevant variables with ward being the most important variable because it is the only one that we can relate to the crime data set. Ward is a measure of location within the city of Chicago. We grouped this data set by ward and arranged it, and then that allowed us to create several other data frames of our relevant variables, such as number of schools per ward, average ACT per ward, and average attendance per ward. Now that we have those data frames created, we also narrowed down our crime data to only theft and for the year 2011, so we can directly compare it to the education data from 2011. Now we can create a data frame called thefts per ward that shows the total number of thefts per ward, and we can join these data frames by the variable ward, coming up with a complete data set with ward being the only variable in common, and thefts per ward, average ACT, average attendance rate, and number of schools per ward being the following variables. This allows us to begin our analysis to see which wards are the worst for theft, so the top 15 wards for theft, along with which you can see here, or we can depict graphically with ggplot. So 42 being the highest, 2 and 27 ranking up there high as well. Now we're going to use these to compare to see if these wards are consistent with the wards that have the lowest ACT scores and lowest attendance rates. So here are the top or bottom 15 wards for ACT, which you can depict graphically. And 27 shows up again with 48 and 2, so we're starting to see some consistency. We'll do the same analysis with the bottom 15 wards for attendance, with 2 showing up again and 48. So it's possible that there could be a relationship between the number of thefts that occur in a ward and how the schools within that ward perform, measuring it off of attendance rates and ACT scores. Now, to confirm or deny our hypothesis, we will perform some statistical test. So a simple test that we did was we tested for the correlation coefficient for the number of thefts and the average ACT, which showed to be 0.25. So that's a weak positive correlation, so it does not suggest much and may not be useful for our analysis. However, looking at the plot, you can't draw too many conclusions, but you can see a very weak linear relationship. Similar results will occur for number of thefts and average attendance rate with a slightly negative, weak linear relationship, which makes more sense logically because we suspect that as theft increases, that we will see a lower attendance rate within those schools. And moving on, our first statistical test did not prove to be successful, so we attempted to evaluate whether or not theft would be a good predictor in a linear model for the average ACT score of schools or the average attendance rates. And the output proves that it's not. So we have a p-value of greater than 0.05 here for the number of thefts within a ward to predict ACT, so it's not a useful predictor. And similarly, theft is not a useful predictor for average attendance rate here because our p-value is greater than 0.05. So even though our statistical analysis proved to be wrong and disproved our hypothesis, we still found some research that supports our hypothesis, saying that areas with higher crime make it more difficult for students to make their way to school, or the lower income areas where students are more likely to be arrested for theft. Now, to depict the data that we were analyzing, we created a Shiny app and made it deployable with the Shiny tool. So here's the code inserted as comments because it will not run within the R Markdown, just so you can see how we created it. We created our UI here, and we set up the headers that are going to be across the top of our app, along with the drop-down menu here for the types of maps that we're creating, along with a drop-down menu for the types of plots. And then here's the server for the outputs of each map, along with the outputs for each plot. So taking a look at our app here, you can see that we have a drop-down menu for theft, burglary, narcotics, and homicide. And each of these maps are a cluster map that allows you to zoom in and out, and the clusters get smaller and more detailed as you zoom in, and you can get to the point where you see exactly where individual burglaries in this case occurred on the street. And you can do the same with narcotics, or the same with homicide and theft. Now the plots, which you've already seen here for the top 15 wards for theft, the lowest wards for ACT scores, and the lowest wards for attendance rates. This is a useful tool for someone who wants to break down where these happened in Chicago and possibly use it for further analysis, testing it against other variables later.
To incorporate the web scraping aspect of data analysis into this project, we decided to use web scraping to assist our research in Chicago's crime. We went onto NBCChicago.com and their local news, scraped up some of their top headlines and created a function that spat them out to us. By running the function, we can see there are already several headlines in here relating to violent crime and criminal activities. Second man charged in fatal shooting of mom at phone store. This begs the question that if this stuff is going on in the mainstream, what's going on behind? To further analyze the data, we used a new package called the R waffle package, which is a way of displaying our data similar to a pie chart. We broke down the ACT score data set and the school data set into ACT scores and attendance rates. We made 5 equal bins of all schools and ranked them by their ACT score and student attendance, and created squares indicating the number of average thefts occurring in each ward. You can see here that the bottom 40% of both graphs, the bottom 40% of all wards, percentile, committed on average more than 50% of the crime, which does indicate a connection between ACT scores, student attendance, and crime rates.
So in conclusion, we believe that the City of Chicago should take some action to try to decrease crime in these particular wards that have high theft rates, and along with lower ACT and lower student attendance rates. The same statistical analysis could be used for other variables that may prove to be more useful, but we still suggest that the mayor invest in the police that have jurisdiction over these wards, and possibly invest some more money into the schools to increase education, or to increase education about crime and how to avoid it. And so some of the wards that this could be useful in would be like 2, 28, 6, and like 27 that showed up on the charts for all of the variables that we looked at.
This concludes our crime analysis project. Thank you.